Hello friends, welcome to bispsolutions.com. My name is Sumit and I'm a data analyst in Python with BISP Solutions. Today I'm going to talk about the linear regression in Python. So it's a part of a predictive modeling. So what is linear regression? So it's a basic and commonly used type of predictive analysis, and it's a statistical technique which is used to analyze or to predict the direct relationship between dependent variable and one or more independent. So linear regression available in data analysis is a good tool for quick predictive analysis. For example, the piece of a house depends on various factors such as its size or its location, and in order to see the relationship between the house price and the variables, we need to build a linear regression which which will be going to predict the line of best fit between them, and also help to conclude whether or not these two factors has a positive or a negative relationship. And linear regression is one of the most easiest algorithm in machine learning. As the name suggests, this algorithm is applicable for regression problems, and also it's a linear model, and we can establish a linear relationship between the input variable x and the single output variable y, where when the input x is a single variable, this model is called a simple linear regression, and when we have multiple input variable x, then we used to call it as a multiple linear regression. So in today's video we'll be going to talk about simple linear regression. In next upcoming videos we'll be going to discuss about multiple linear regression. So first of all, let's try to understand the linear regression equation. And the linear regression equation is y is equal to mx plus c, where y stands for dependent variable, x stands for independent variable, m stands for slope of line, and c stands for intercept. We can also consider we can have one more equation for this, which is called y is equal to 0 plus b1 of x, where b1 is the scale factor or the coefficient matrix, and b0 is called the bias coefficient. And this bias coefficient, it gives an extra degree of freedom to the model. But we will be talking about y is equal to mxc. This equation is for simple linear regression, and we can, if we compare this and this, so we will be considering m as the slope and b is for intercept. So we can consider that b1 is equivalent to m and b0 is equivalent to c, or the bias coefficient. So in linear regression, in simple linear regression, we would like to draw a line between x and y, which estimates the relationship between x and y. So this example we will be going to do in two ways. So first way is we can find out the slope and the intercept separately, or we have an inbuilt function which can be used to figure it out, the slope, and to get the slope and intercept. So we would be going to see both the formulas, and we'll see that how, whether the results are same or not same, and then we will be trying to place the same on a scatter plot chart in Python. So let's begin. Let me cancel this, and let me get back to the Python and create a new file in Python ideally. And the very first command, I would be going to import pandas. Import pandas as pd, and import numpy as np. And to plot, I will write import matplotlib dot pyplot as plt. I'm going to add couple of more libraries. So I use from scipy import stats. So we have included all the libraries. Now let me show you the data which I'm going to use. So on my C drive, Python 36, there is a data set called salary.csv, and let me show you the data. We have salary as salary and experience, education and management, and here we have two matrix values. So basically salary is dependent on experience. More experience you gain, more your salary will get increased. So I just wanted to find out the linear regression using these two attributes, salary and experience. So it's a CSV file. So the very first thing, the very first command would be, I'm going to take help of pandas to read the CSV file into and store into salary variable. CSV read underscore CSV salary dot CSV. And in I'm creating two variables x and y, because in equation we would be requiring two equations. We need x and y, so I'm creating two variables here. X is equal to np dot array, and it would be stored as an array, salary dot experience, and y is equal to np dot array salary dot salary. So basically salary will be dependent on experience. So here x is independent variable, and my y will be dependent variable. So salary is directly dependent on experience, and we would like to place this by with the help of linear regression. So first of all, let's do the easy way, where we would be using the inbuilt formula, and we are not going to write any command. Means we are not going to calculate the slope and intercept separately. So first of all, I need slope comma intercept. I'm requiring slope, intercept, comma r value, comma p value, comma standard error, and we can use it by stats dot linear and line regress x comma y, and let me test it. So save it, and I save this as regression 3.py matplotlib matplotlib.pyplot.splt. No error. Let's try to print the values of slope. So I just print the value of slope. So the value of slope is 491, and that's the slope. So we can print it all together. So I just write y is equal to %f(x) plus %f, then r is r value, so it would be printing r value. So %f comma r squared %f slash n, then we will be printing p value, %f standard error, %f percent, and variable is in the same sequence, slope, intercept, r underscore value, comma p underscore value, comma standard error. And one more, that is r squared. So for r squared, that would be the square of r. So I'll write r squared, r underscore value multiply 2, and let's test it. So we got the values intercept, okay, intercept, intercept. Right. So some syntax error was there. It's resolved now. And now you can see we have got the values for y. That's a slope. And r value. That's r value. This is r squared value. That's a p value. And we have a standard error. Now what exactly these indicates? If we talk about what exactly this r value is doing, what do we mean by r value? And what do we mean by p value? So this r value indicates the correlation coefficient between two variables. That's a correlation coefficient. P value is basically, it's a two-sided p value for hypothesis test, whose null hypothesis is that the slope is 0, and then standard error is to find out the standard error of the estimated gradients. Then we have slope and intercept. Slope is used to find out the slope of the regression line with respective to two variables, and intercept is the intercept of the regression line, where that line would be going to intercept. So these are the values we got: slope, intercept, r values, p values, and standard error and standard regression line. And now let's try to plot this using scatter plot chart. Now to plot this on a scatter plot, or to create a to create a regression, first of all let's try to plot this without regression. So write plt dot scatter x comma y comma color is equal to red. So when we test it, plt dot show, when I test it, it simply displays the r values and x values at the x values and y values, or you can say the dependent and independent values without regression line. So let's customize it more, and let's set the labels. Plt dot x label experience in years, and plt dot y label salary. So let's test it once again, and y label label, sorry for the mistake, label, and test it. We have x label and y label. So we got, so that's a scatter plot chart without regression line. Now I want to add a regression line, and to find out the regression line, the formula is y is equal to mx plus c. Now from the above formula which we have defined just now, we have found the slope and the intercept values, and y and x value is already there. So what we do is we create a regression line. So we write a formula: regression line is equal to slope into x plus intercept. So slope we would be getting from here, intercept we are getting from here, and x value we have. So we will be finding out the regression line, and now this regression line we will plot on this chart. So plt with respective to x, so x comma regression underscore line, and let's test it. So you can see a regression line is added, which is showing the dependencies between two variables, dependent and independent variables, and this line is positive. This is showing more experience, more salary. So this says the independent variables are dependent on experience variables. So this is one way of defining a regression line where we use the inbuilt formula for stats for line regress using, which is coming from SciPy. So SciPy is mainly used for scientific calculations. We can also find out the slope and the intercept using formula. So these are the expressions for finding out these to calculate the slope and intercept. To calculate slope, mean of x into mean of y minus mean of x into y divided by mean of x square mean of x square minus mean of x power 2, and this is to calculate the slope, and this formula is to calculate the intercept. So that's the intercept is equal to mean of y minus mean of x into m. M is which we would be getting from the slope. So let's try to implement the same formula, and for that I'll just mark them all of them as comment, and I would be writing a formula first. So I would be looking for m. So m is equal to np dot mean of x np dot mean of y divided by np dot mean of x into it should be, the formula is mean of x into mean of y minus mean of x into y. So mean of x into mean of y minus np dot mean of x into y. Mean of x into y. That's the formula for the top level, and then divided by mean of x square and mean of x, the square of x. So divided by np dot mean of x into np dot mean of x this would be mean of x power 2 minus mean of x2. So np dot mean of x into np dot mean of x minus np dot mean of x into x. So 1 and 2 brackets. So let's look at the brackets. One is for this one. We need to be very careful with the brackets. Fine. Okay. So let me do one thing, because we don't have regression lines right now. So let me mark them as comment. We first wanted to test it, and no error. Let me print the slope. So print slope is equal to comma m. So we got the slope. So slope is 491, and here also when we got the slope, let's test it whether slope is same or not same by getting the formula. So here when we are calculating slope by using the formula, that is 491, and the slope which we get by using the inbuilt formula function, that is same. So we got the same result, slope. Now we need to calculate the intercept, and intercept is mean of y minus mean of x into m. So to calculate the intercept, c is equal to np dot mean of y minus np dot mean of x into slope, which we got here, and then a simple print intercept is equal to, and I'll just test it. So you see slope is 491, intercept is 135. Here slope is y is this, and slope is 13. So the values are almost same. Now we can use this m and this x to calculate the to find out the regression line. So instead of using the slope, instead of using this slope, I would be using the, so regression line is equal to m into x plus intercept. So x, I'll say m into x plus c. So we got the complete formula, and we have x comma y and regression line. Let's test it. So you can see the result is same. So that's how we can create a simple regression which is used to show the dependency between two variables. Whether it's a positive regression or negative regression depends on the value. So based on the result, based on the linear regression, we can decide whether the what would be the prediction, and we can predict the future according to that. So that's all in this video. In my next coming video, I will be going to talk about multiple linear regression. Thanks for watching. Have a nice day.